roots of unity. So basically the cube root of unity are the cube roots of 1 because unity means 1. The cube roots of unity can be defined as the numbers which when raised to the power of 3 gives the result as 1. So basically we have 3 cube roots of unity and these are 1. Next one we have is minus 1 plus under root minus 3 over 2. Next we have minus 1 minus under root minus 3 over 2. Since these two roots have a sign of iota, because minus 3 it means minus 1 minus 3. So this minus 1 in the form of under root is iota. Since these two terms contains iota, so they are called the complex cube roots of unity. These are called complex cube roots of unity. This is written as 1. Let me write this root as omega and this root as omega square. So 1, omega and omega square are the cube roots of unity. Now we will see what are the properties of the cube roots of unity and then we will solve some problems related to this concept. So we have the properties of the cube roots of unity, and property number A says each complex cube root of unity is a square of the other. This is the cube root of unity 1 and these two are the complex cube roots of unity. It means if we take the first one root and we take a square of this root, it will be equal to the other root. As you can see here, minus 1 plus 3 iota over 2 whole square. So its square is equals to the other one root. And if we take the square of this root, it will be equals to the square of, so its square will be equal to the first root. So it means if we have two roots, complex cube roots omega and omega square, so each of the square is equals to the other. Next one we have is the sum of 3 cube roots of unity is 0. So it means 1 plus omega square, it is equals to 0. This is a very important result, that the sum of 3 cube roots of unity is equals to 0. Third one is the product of the cube roots of unity is 1. We have 1, omega and omega square as the cube roots of unity and their product is equals to 1. And last one is any imaginary cube root of unity is equal to the reciprocal of the other imaginary cube root. So omega and omega square, these are the two imaginary cube roots. So they are the reciprocal of the other. It means we know that 1 dot omega square is equals to 1. 1 dot omega is omega and omega square is equals to 1. From here we can say that omega is equals to 1 over omega square and omega square is equals to 1 over omega. It means any imaginary cube root of unity is equal to the reciprocal of the other imaginary cube root. So in this video I have only explained you what are the properties. I have not done their derivation in this video, but if you want me to do a derivation for all of these properties, you can ask me in the comment section. I will make a detailed video on the proofs of the properties of cube roots of unity. So now we will see few of the examples and we will see how we can solve these questions. Very important result, it says omega raised to power n plus omega raised to power n plus 1 plus omega raised to power n plus 2 is equals to 0. So we will see how we can prove this result. Omega n plus, this is we have omega n plus 1. We know that when bases are same, we can add their powers. So it means we can write it like this as well. So we will split it into w raised to power into omega raised to power n into omega plus omega raised to power n into omega square. We have taken the left hand side. Now this term has omega n, this term has omega n, and this term also has omega n. So we can take omega n common. Now here we have 1 plus omega square. And we know that the sum of the three cube roots of unity is 0. So it means omega n, now this term will approach to 0. And something when it is multiplied with 0, we have the answer 0, which is our right hand side. So this is a very basic and important result. Let's move towards the next one. Next question we have is, if 1, omega and omega square are the cube roots of unity, then prove that 1 minus omega plus omega square whole square plus 1 plus omega minus omega square whole square is equals to minus 4. 1. We will write the positive term first. It makes our question easy to solve. So 1 plus omega square minus omega and a whole square plus 1 plus omega minus omega square whole square is equals to minus 4. Right? So first we will take the left hand side, this one term. As we know that 1 plus omega square is equals to 0. It means 1 plus omega is equals to minus omega square, and 1 plus omega square is equals to minus omega. So this is we have 1 plus omega square, which means minus omega square plus 1 plus omega, which means minus omega square whole square. Minus omega, which means minus 2 omega whole square plus minus omega square, which means minus 2 omega square whole square. So here we have minus 2 square and omega square plus minus 2 square omega square, which means omega 4. So minus 2 square is 4 and omega square plus minus 2 square is 4 and omega 4. So this term has 4 omega square, this term also has 4 omega square. So we will take 4 omega square common and we have 1 plus, so we have 1 plus omega square, because we have omega 4, so we have taken square common, so 1 square will be left. So 1 plus omega square, which means minus omega, 4 omega square into minus omega. Now this is equals to 4 minus 4 omega square into omega, which means omega cube. Now this is a very important result, that omega cube is equals to 1. So minus 4 into 1, this is equals to minus 4. So in this way we have proved our result, and this is right hand side. In the coming videos I will make a video in which I will tell the 3 ways how we can solve that omega cube is equals to 1. So stay tuned. Last one question for this topic is omega n into omega n plus 1 into omega n plus 2. This is equals to 1. So how we can solve it? omega n dot, we can write it as omega n dot omega. Then we have a product sign, omega n into omega square. This is the left hand side. Very simple proof. Now we have omega n and omega n 3 times. So we can write omega 3n. When bases are same, their powers can be added. And we have omega and omega square left. Omega 3n. Again, when bases are same, their powers can be added. So this is 1 plus 2. Omega 3n dot omega 3. Omega 3 is equals to 1. So omega 3n into 1. This is omega 3n. Now we can write omega 3 raised to power n. Omega 3 is 1 raised to power n, and this is equals to 1. So first question we have is minus 1 plus under root minus 3 raised to power 5 plus minus 1 minus under root minus 3 raised to power 5 is equals to minus 32. So how we can prove this? We will take the left hand side of the equation. This is the left hand side. Minus 1 plus under root minus 3 raised to power 5 plus minus 1 minus under root minus 3 raised to power 5. For solving purpose, we will multiply and divide both of these terms with 2. And why we have done this step? Because minus 1 plus under root minus 3 over 2 is the cube root. This 2 was missing. So in order to introduce in the division, we have to introduce in the multiplication as well. So now this term is now equals to omega. This term is equals to omega. This 2 will be written as it is, and we have raised to power 5 plus 2. Now this is equals to omega square and raised to power 5. So 2 raised to power 5 and omega raised to power 5 plus 2 raised to power 5 and omega raised to power 2 into 5, which means 10. So 2 raised to power 5 will be taken common, and we have omega raised to power 5 plus omega raised to power 10. Now 2 raised to power 5, which means we will multiply 2 5 times. So 2 times 4, 2 times 8, 2 times 16, and 16 2 times is 32. 32 into, now we can split these powers of omega as well. Like we can write omega cube into omega square, which is ultimately equal to omega 5 plus omega 10, which means this is equals to omega 9 into omega. So 32, omega cube is equals to 1, and 1 into omega square is omega square plus omega 9. We can write it as omega cube dot omega. So 32 omega square plus omega cube is equals to 1, and the cube of 1 is 1 into omega. So 32 omega square plus 1 into omega is omega. Now we know that the sum of the cube roots of unity is equals to 0. So omega plus omega square is equals to minus 1. So 32 into minus 1, this is equals to minus 32. So in this way we have proved this result. Let's take another example. So next question we have is, show that 1 plus omega into 1 plus omega square into 1 plus omega 4 into 1 plus omega 8 up to 2n factors. This is equals to 1. Let's solve it. We will take the left hand side of equality. We will take the left hand side of the equality and we have 1 plus omega into 1 plus omega square into 1 plus omega 4 into 1 plus omega 8 up to 2n factors. This is our left hand side. Let me write it as 1 plus omega into 1 plus omega square inside one bracket, and we write the other two terms inside the other bracket, and we have 1 plus omega 4 into 1 plus omega 8. So 1 plus omega we will write as it is 1 plus omega square. We will solve this term first. And how we will solve it? 1 plus omega 4, which means we can write it as 1 plus omega into omega square. 1 plus omega 8, which means we can write it as omega 2 omega 6. Bases are same, then their powers can be up to n factors. This is one factor, this is other, and up to n factors. Now 1 plus omega square. This is we have 1 plus omega dot omega square. Sorry, this is omega into omega cube. Now omega cube is equals to 1 and 1 into omega means omega. So we will write 1 plus omega. Now this is omega square into omega 6, which means omega square. How we can solve this part? Omega 6, which means omega cube square. Omega cube is 1, 1 square is 1. So 1 into omega square is omega square up to n factors. So as you can see, 1 plus omega square. 1 plus omega square up to n factor. This term will approach like this. Now since this is approaching up to n factors, so we can write 1 plus omega square whole power n, right? And each bracket is 1 plus omega into 1 plus omega square. Now 1 plus omega square is equals to 0. So 1 plus omega is minus omega square and 1 plus omega square is minus omega raised to power n. So minus is plus, omega square into omega is omega cube raised to power n. Omega cube is 1 raised to power n and 1 raised to power n is equals to 1. So we have another question. Evaluate omega 28 plus omega raised to power 29 plus 1. We have to prove that this term is equals to 0. So we will take omega raised to power 27 common from first two terms, omega 27, and we have left omega plus omega square. Plus 1 will be written as it is. This is omega 27, omega plus omega square. 1 plus omega square is equals to 0. So omega plus omega square is equals to minus 1. Minus 1 plus 1. Now we have to calculate omega 27. We can write it as omega 3 omega cube raised to power 9, because 3 9 times is 27. Now minus 1 and this plus 1 will be written as it is. Omega cube, this is equals to 1. 1 raised to power 9 into minus 1 plus 1. 1 raised to power 9 is 1 into minus 1 plus 1. So minus 1 plus 1 will be cancelled out and answer is 0.